Today we're going to look at a lot of different types of function rules for different functions, both linear and nonlinear, and we're going to look at how we can graph those functions in the coordinate plane. Now we're going to use our graphing calculator to help us do this. In our next unit we'll look at how we can graph linear functions like this one, y equals x minus 3, using what we call a slope and the y-intercept. But until we get to that point, we're going to graph functions using a table of values. And now instead of going through plugging in x values, doing the calculations by hand to get the y values, we're going to use our calculator to do this. So you're going to go ahead and you can get your calculator. Remember, you always want to start with that RAM cleared screen. We can get there by hitting second, plus sign, 7, 1, 2. And the first thing we're going to do when we want to graph is go to the y equals screen. So our function there was y equals x minus 3. Remember, we use this x button here for x. Use the minus button for 3. And now if I want to see what this function looks like, I can hit the graph key, and I can see that it's a linear function, increasing as we go from left to right. But now I really want that table of values. So I'm going to hit second, graph, to get to the table. And now I have a table of all of the appropriate y values for my x values. And this is what we're going to use to graph those different functions. If I want to change my function, I just go back to y equals, hit clear, and I can type in a new one. So the first function that we want to look at is y equals negative 2x plus 4. If I want to put that in my calculator, I come back to y equals. We make sure we hit the negative button and not the minus button so we don't get a syntax error. We type in 2x plus 4. We can graph it to see what it looks like. We can see again that this one's linear, but now this function is decreasing as we go from left to right. And to get to the table, we just hit second, graph. So now I'm going to come back to my notebook here, and we're going to start to fill in our table. Anytime we fill in the table, we want to make sure that we get a good representation of points for that function. So I always want to make sure that I try negative values, positive values, and 0. So if I start with 0 here, when we plug in 0, we check the table, we see that y is equal to 4. If we plug in 1, we get y is equal to 2. If we plug in 2, we get y is equal to 0. But I also want to check some negative values. So if I try negative 1, we get 6. If we try negative 2, we get 8. And that's actually going to be off my graph, so I'm going to come back in the positive direction. We'll try 3, and we'll get negative 2. Now all I do is plot these points on the coordinate plane. So we have 0, 4. Remember, my first coordinate is my x coordinate. That's my side to side. My second coordinate is my y coordinate, which tells me how far up or down I'm going to go. We have 1, 2, 2, 0, negative 1, 6, negative 2, 8, which is going to be just out of reach up here, and then 3, negative 2. Now, because I'm graphing the function rule and not just a set of points that was given to me, I'm actually going to connect the dots here, because my function includes all of the values in between all the dots that I've selected, and we put arrows on both ends to show that that graph keeps going in both directions even though I didn't graph the individual points. This is a linear function because all of the points lie in one semi-straight, because I can't draw without a ruler, line that we can define with this rule. We also look at linear functions as having x to the first power. Remember that anytime we don't write an exponent there, it's the same as being to the first power. So go ahead, pause the video, and see if you can draw the graph of this linear function. Alright, so if we look at a graph like this, we're going to make sure we're careful with our scale. You'll notice that both axes are scaled with a step of 1. So if you put odd integers in here, just keep in mind that when you get those decimal values, you're going to want to be careful as you plot those points in between. But again, this is linear. We have that x to the first power, that y equals something times x, and this is what our graph will look like. Alright, now we're going to look at a nonlinear function. This function has x raised to the power of 2. So this is a quadratic function, and we'll spend a lot more time with these in the spring. You don't need to remember the name quadratic for right now, but just so you know. And this is not going to be linear. So remember that when we want to put those squared values in our calculator, we're going to come back to y equals, we'll clear this out. We have x, and then we use the squared button. And then what else do we need? Minus 2x, we use our minus button, minus 2x, and then we can hit graph to look at our picture first. We'll see this one is clearly not linear, and then we'll go to our table, and we can plot our individual points. Now if you look in the table, you'll see a little bit of symmetry. My graph starts to decrease, and then it starts to increase by the same amount. So these are the points that I'm going to want to capture in my table. So we come back to our notebook, and we just start plotting those points in like we did before. So, we'll full screen this again. Remember, we want to check both positive and negative values to make sure we get a full picture of that graph. So I'm going to start with -1. We had 3, 0, 0, 1, -1, 2, 0, 3, 3, and 4, 8 is going to be just beyond our reach. So we have -1, 3, 0, 0. Plot all our points here. And this other one's going to be up here. Now when we draw this, we're going to do our best as we can to kind of show the curve of the graph. And we still put those arrows now on either end to show that this graph continues even though we're not drawing the points in. Our last function is an absolute value function. And to put this into the calculator, we have to use that ABS option. So we'll go back to our calculator. We'll clear everything out of here. Remember that to get to absolute value, we want to go to Math, over to Number, and then we take the absolute value option, and then we just type our expression in. So we had x plus 3, and we can go to the table to get our values. If I scroll up in my table, you'll notice that we have that same decreasing, increasing effect we saw with the quadratic graph earlier. So pause the video, fill in your table, and take a look at what the graph would look like. Alright, this is one example where we don't necessarily need to try a positive value for x to get a full complete picture of the graph, because you can see we see what this looks like even though we only did negative numbers and 0. And that's where your graphing calculator can really help you get a preview of what the image that you're graphing should look like. We do want to make sure, however, that we get both sides of the graph. So if I only graphed this right side part and I missed the other arm, my graph wouldn't be complete because that wouldn't really give us a good idea of what it looks like. So we want to make sure that we graph the whole picture here. And you'll be able to, again, to use your calculator to preview and see what those points look like. Again, this is non-linear because I can't draw just one straight line to connect all those points. Okay. Something else that we want to be able to do is to figure out which function rule matches a table of values. One way that we can do this is by taking our x values, substituting them into each rule, and seeing which one matches. So here, if I take -2 plus 6, that's going to give me 8, which isn't 12, so I know it's not this one. I can check the others. Here we get 5, which is not 12. Here, we're going to get 12, so this is a possibility. And then here, we're not going to get 12. So this is not a possibility. So the only possible answer is this one. A little bit later on, again in our linear functions unit, we'll look at how to use slope or our rate of change to match up tables and equations. And sometimes you want to keep in mind that you might get 2 equations that work for the first point, then you just check another one to see which matches. Go ahead, pause the video, and see if you can figure out which rule matches this table. So again, we can just substitute in the first point. Another good rule of thumb, in the last question we had an x coordinate of 0. Ooh, that's usually, ooh, the pen is going crazy. That's usually a really good option, not sure what happened there, to plug in, because we know that 0 is really easy to work with. Here we didn't have 0, so I just went with the first point. We substitute in that x value of -4, and we get that our equation that works is y equals 1/2 x plus 3. Alright, the last question we have is very similar to the one that we just looked at. We have a relationship between x and y in the table, and we want to figure out which equation matches it. So go ahead, pause the video, and see if you can find the answer. Alright, so for this one, when we try the first point, shown in red, 3 of our options end up working. And you'll notice this is an SOL question, so they like to do this. A lot of people might get excited when working this question. It works on the first equation, they select that as their answer, they move on. But unfortunately, you'd be incorrect. If we move on to the second ordered pair, 1, 2, when we plug that in, it only works with the third equation. So again, you have to check every equation when it's multiple choice, because there may be some that work for that first point, and then check the other points to double check and make sure that they're the correct equation.